takes away 2 hydrogens. So if we were to look at this question.
Why'd you draw an arrow from aliphatic to cyclic hydrocarbons? I thought you said they're not cyclic.
That's the thing. Read this again. These are as common as non-cyclic compounds. These are known as aliphatic.
Oh, so okay, so non-cyclic compounds are aliphatic.
Now you got me questioning it. These notes are weird. Let's look it up. Aliphatic.
Aliphatic are ones that are not aromatic rings and form open chains.
Okay, there we go. So this is this. Thanks. Non-cyclic compounds. So let's just get rid of the arrow altogether. Boom. So cyclic hydrocarbons, these are common as non-cyclic compounds known as aliphatic. These cyclic hydrocarbons are called cycloalkanes, cycloalkenes, and cycloalkynes. So again, they will not have the maximum number of hydrogens as a non-cyclic compound because you have them going back around to each other. So that means that you're going to have one extra, like for example, if you had propane, we have CH3, CH2, CH3. Well, if we were to bond these two together to make cyclopropane, we lose these 2 of these hydrogens, one from this carbon and one from this carbon. So that means that all of these then have CH2. So just to keep in mind that as you go back on itself from that normal CnH2n plus 2, we're back to CnH2n. So this would be C3H6 versus C3H8. So there we go. Cyclobutane. Why is this cyclopropane? Why do you think that that's not very stable? Anybody? Think about the last chapter. Nobody. Well, what does the angle of this have to be?
$60.
Yeah, right. And what should the angle be for something that is 4 bonds, 0 unshared pairs?
109.5.
Right? So this is not stable because that's a very difficult angle to be with 1, 2, 3, 4 bonds and 0 unshared pairs. You should be at 109.5. So this is not very stable. What are the angles here on the cyclobutane? 90, right? So what should the angle be again? Well, 109.5. So again, not very stable. There's actually a very cool compound called cubone. And it actually has carbons here, 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 and here, and here, and here, and here. And actually makes a decent explosive. Basically, those angles are not good either. Right? You doubled the amount of 90 degree, well, even more than doubled the amount of 90-degree angles. But all we have to understand here is if it's made of 3, it's still prop. And since it doesn't have a double or triple bond, it's propane. The fact that it comes back on itself, it is cyclopropane. Cyclobutane. Here we have a methyl cyclohexane. We keep in mind we could call this 1-methyl cyclohexane, but we don't need the 1 because there's only, it would be on the lowest number anyway. But what if we had this one here? What would we name this?
1,2-dimethyl cyclohexane.
Right? We still know it's cyclohexane. We have 1,2-dimethyl. Cyclohexane. Which one's the one? Which one's the two?
It doesn't matter, does it?
It doesn't. 1, 2 or 1, 2. Does it matter now, Emma?
Yeah, because you want to have the lowest numbers.
Good. So instead of being 1, 2, 5 trimethyl, it's 1, 2, 4 trimethyl. Does that make sense? So now we actually need to know that this is number 1, this is number 2, this is number 4. Finish 1-butyl 2,3-dimethyl cyclopentane. Go ahead and draw it on there. Or on a scrap paper if you have it. There's my 1-butyl. So what does that mean? 1, 2, 3. 2,3-dimethyl.
Could we have put the butyl group on top and gone down to the right? Does it matter?
Could you?
I would think so.
Yeah, right? Where'd you put it? All the way on top?
Yeah.
1, 2, 3, 4. Like that?
I did it to the right, the 2 methyls to the right, but I don't think it matters.
Right? Keep in mind, we can turn that any way we want, right? It's not going to matter. This one looks like that Pikachu thing, though. But yeah, it's not going to matter. The carbons with the double bond or triple bond are always assigned the number 1 and 2. So try to draw either on scrap paper or on here 3-methyl cyclopentene. One, 2, 3. What's the hybridization of this carbon here?
SP3?
sp3. Because even though it's not drawn on there, remember it is bonded to a hydrogen as well. What is the hybridization of this one right here?
SP2?
sp2, right? sp and then to a hydrogen that we don't see necessarily. Questions there? Two. Then here's 2 pages for you to have fun naming all this junk, right? So let's try this one. What's our cyclo?
Cyclopentene.
Cyclopentene. All right. What do we have on that cyclopentene? Pretty quiet today. It's like second Monday.
1,2-dimethyl.
1,2-dimethyl works for me. 1,2-dimethyl cyclopentene. We could also call this 1,2-dimethyl 1-cyclopentene. No need though. We know that pentene is going to be, the double bond is going to be on the lowest carbon number. You want to try this one? That one looks a mess. So again, you always just start with your rules. What's the cyclo, Gabe?
Pentene.
Pentene or pentane?
Pentane.
Pentane? Is this the class with the, is it Owen that never says any words to me? He's good. You know, this came up today. Your name came up. Somebody said, do you know Owen Smith? And I actually told them I didn't. Because he never talks to me. Who was that? Somebody in my period period 5-6, I think. All right. So how about Jonathan? John or Leonardo? What groups do we have on here? It looks crazy ugly. We don't have to look for a long chain on this though, because the name pentane is going to be the chain we're using. So that's the root now. Now we got to look at see what's sticking off of this pentane. So what are some things that are sticking off the pentane?
A couple ethyls, it looks like.
Yeah. And out of ethyls and methyls, which one do we want to give the lowest numbers to?
The ethyl, right?
Yeah, the ethyl, right? Silly, like it's one of the silliest things, but it is alphabetic order. That's all it is, right? So if we call this one 1, we're probably going to call this one 2 and this one 3. We call this one 1, 2, and 3, but it doesn't matter because it is the same thing. So that means we have 1, 1. How many ethyls do we have? These are ethyls as well.
Or no, 4. Yeah, 4.
1, 1, 3, 3. Right? What is the term for 4 of something?
Are you still asking me?
Whoever, go for it. Just assume that I'm always asking Owen, but he's never going to answer me. So you can cut in anytime you want.
Is it tetra or?
It is. And what's going on after that tetra? What do we have 4 of? And it looks like I didn't probably leave enough space. Tetra,
Ethyl.
ethyl. What's left? I don't know what's left.
There's 2 methyls.
There are 2 methyls. What are they located on? If this is 1, then they are located on
2. Yeah. Okay. Cool.
2. Good. 2, 2. And that is dimethyl.
You forgot the cyclo.
Thank you. Cyclopentane. 1,1,3,3 tetra methyl 2,2-dimethyl cyclopentane. That's the thing about this. You know, if you saw that, you might sit there and go, what? And your whole brain might shut down. But if you know these rules, you sit there and you go, okay, cyclopentane. All that means is that we have 5 in a circle, right? 2,2-dimethyl. That means on the second carbon, there are 2 methyls. Well, where is the first carbon? Well, the first carbon has 2 ethyls on it. The second carbon has 2 methyls on it. And the third carbon also has 2 ethyls on it. You know, it may sound complicated, 1,1,3,3 tetraethyl 2,2-dimethyl cyclopentane. But we have all of these rules that allow us to break that down in order to get the answer we want. What if we had Let's see if you can do this one. 1-chloro, and you wouldn't even need the chloro on here. 1-chlorocyclopentane. One chlorocyclopentane. Can you draw that? Langston, how many sides is our cyclo going to have? You think Langston and Owen are together?
5.
5, there we go. How do you draw a 5-sided thing? Are you guys any good at this? Mine always look like home plate. But basically we get 5 done, right? And what does it mean if it's pentene? That means we need a double bond. I'm going to go ahead and put that double bond right there because that part always already looks silly anyway. What does chloro tell us?
You have a chlorine attached to one of them.
Right? We have a chlorine attached. I'm going to put that right there to try to make that not look as bad as it did before. 1-chlorocyclopentene. Boom. What if we had another chloro right here? Now it would be 1, 2, dichloro cyclopentene. Right? Which one's the 1 and which one's the 2?
Doesn't matter.
Doesn't matter. These would be called para because they are next to each other. If instead, like right here, if this ClH3 wasn't here and it was right here, that would be called meta. And if it were opposite sides of it, that would be called ortho. But I don't think that's going to be on the test. Might be on that thing you are taking, Akshay, but I don't think that's going to be on our test. I don't know how hard that one is. All right, let's do one of these and we'll talk about benzene and then we'll end it. Which one do you want to do? 8, 9, 10, 11, 12, or 13? It's funny, usually people ask for the highest number, but what's that going to do in this case? That's weird.
Number 11.
12 and 13 are the same, aren't they? Let's change it.
I mean, one is pentane, the other is pentene. They're not the same.
Oh, okay. I can't tell the difference between an ane and an ene. Thank you. We don't need to change it that much then. So 1,3-dimethyl cycloheptane. Why did you ask for this one?
I don't know because it seemed the longest. And oh, yeah.
You know I can't
Double.
do heptane, right?
Yeah, it might be hard to draw.
Is that why he did it? What do we have to have? What does a heptane even look like?
7 sides. I don't know how to draw
All
that.
right. 1, 2, 1, 2, 3, 4, 5, 6, 7. Like a little bit lopsided stop sign. It is cycloheptene, so we are going to have a double bond, and I'm just going to put it there. And it is 1,3-dimethyl. So there's the 1-methyl, 1, 2, 3 dimethyl cycloheptene. Basically, right here, this is flat. That might be one of the best cycloheptenes I've ever drawn. You don't get those that much. But yeah, it's like just like a hexane, which is like a diamond, and then you need to flatten out the bottom. Questions? All right, let's take a look then at aromatic carbons. And if you are struggling with this, these are all of the rules that we've done, put into one place, including all the way down to cyclose. You know, I mean, like I said, this isn't necessarily really chemistry. This is just a naming system, a naming set of rules. We haven't talked about the interactions of a lot of these compounds, or we haven't, you know, next unit, we're going to talk about the boiling points and stuff of them, but this is just naming. Text Andrew Slater. I have some balloons if you need them.
Okay, I'll send this.
All right, so if we take a look, aromatic hydrocarbons, these are a special organic class of unsaturated cyclic hydrocarbons. They are called arenes. The easiest one, keep in mind, these are unsaturated cyclic hydrocarbons. The easiest one or most simple one is benzene. It has its own special name. Benzene is C6H6. Now, I put this here because this would show what? What do we remember from this double arrow thing? When do we draw that double arrow thing with the structure?
It's a resonance.
Yeah, good. Good. It shows resonance. So that means that I need to draw it the different ways that it could be. Well, scientists said, we're not doing that because this is such a simple thing. We're going to just draw it like this. They break their own rules. In reality, we know that probably neither of these exist like that. When we talk about resonance, it's more about delocalizing where the electrons are. Basically, the electrons are just being passed around throughout there. So the electrons are not they're not staying put. They're basically being put around there. And what this does is this stabilizes the structure. And benzene is one of the most common starting chemicals when making any type of organic structure. From it, you would start with this and you start adding stuff to it. It's used in the starting system in making like styrenes and stuff like that, which is styrofoam. Now let's imagine that we have a chain that we all know and love, right? 1, 2, 3, 4, 5. So that is pentane. Now imagine if somebody stuck looks like some type of space monster. Somebody stuck a benzene on there. We would no longer call this a benzene since it is attached to a pentane. We would call that 3-phenyl. Pentane. So if a benzene ring is attached to a chain that you name, it no longer retains the benzene name. It's a substituent, so it has the group with the the YL, just like methyl, ethyl, butyl. We change it instead of benzyl to phenyl. Now, when you hear that, you may actually recognize that if you've ever looked at the backs of packages and looked at their ingredients and stuff like that. You may actually see something say something phenyl or phenyl something. What did I put on the notes? I wonder what I've got right here. Or this or this. I wonder if it's one of these again. Let me take a look. Make sure where I don't forget to tell you guys something. Sorry. Give me 1 second. I know it's in there. I'm assuming that it is just this again. So whatever. Compounds containing substituents attached to the benzene ring are named as derivatives of benzene. So if you have, now keep in mind, this is the actual benzene being attached to the pentane. This is a methyl group attached to a benzene. So benzene is now the main name. This methyl doesn't matter. We could call it 1-methyl, but there's no need. So this would be methylbenzene. Now, methylbenzene actually has a proper name because it's also very common in organic, making things. That is toluene. You may have had a drink that has had toluene in it. Those monster drinks a lot of times have the toluene in there. All right. So if we take a look, methylbenzene, if it were 1-methyl 2-ethylbenzene, well, we make our benzene, 1-methyl 2-ethyl. Right, and so on and so forth. And then look at this fun thing. Here's a benzene with a benzene and a benzene. What is that exhibit or whatever? I heard you like benzene with your benzene. You guys probably don't even know that there used to be a show called Fix My Ride. And this guy would basically take these people's junkie cards and like put like crazy stuff into them. So if we take a look here, benzene on the benzene and then another benzene on the benzene. Well, since these are on the benzene, we don't call them benzene, we call them phenyl. So this is 1-phenyl and this is 2-phenyl to give us 1,2-diphenyl benzene. If you have benzene on your benzene's benzene, then we don't use that. We don't do that. We don't go that far. All right. Cuckoo. I think that's all I've got. Questions? Oh, sorry, I did not see this chat. Oh, the chat answered itself. Good. I like it when the chat answers itself. I don't do good with the chat. I always forget to turn it on. If you don't have any questions, then get out of here. Work up to page 19. This phenyl stuff, I mean, this is the notes. You'd probably only have one of these to name, and it would be something as easy as one of these two things. Or maybe it has like 1, 2, 3 trimethyl benzene. So if you don't get too stuck on that. But the cyclic stuff, yes, make sure you know that. Get out of here and work on page 18 and 19. And I think the answers to them are in the packet of answers from last week. But if you have questions, by all means, stick around. Otherwise, bye.
That's not a question.
Yes.
About that competition I'm doing. So I emailed you about if you could add my outside email to the contacts.
I sent it to him. Yep.
Oh, you did? Okay, thank you.
Yep. Thank you. Brody, how we doing, man?
Doing all right. But I do have a few questions.
Yeah.
Oh wait. Never mind. Okay, so for the first one, it was on page like 17. We were working on that like 3-methyl cyclopentene, and you put like I had my first carbon be at that top. Can I still? And it was like it was the last problem I did. I put my first carbon as like the carbon at the very top. Am I allowed to do that?
Yep. So you have it like this?
Yeah.
Yep. That's fine.
Oh, okay. Then on page 18, I don't see the shape. I just
This one?
yeah, I don't know, like, because I thought like if it has to be like a cycle, it kind of has to be like a closed figure, but I don't see any closure.
Sometimes these can be difficult to see. But if
Uh,
you look, there's that cyclopentane.
oh,
And it might be one of those things where it's just because it's upside down.
yeah, I see that now. And then when we did like you made us like an example of like chloropentene, cyclopentene,
Yeah.
and you put your so when we did it when we originally did it was 1-chloro-cyclopentene,
Mm-hmm.
and you put like your first chloro on the right, like after the pentene, which wouldn't that make it like that on the second carbon?
You know,
Because
I was actually surprised that nobody asked about that. But it is right because I can number this way too. 1, 2.
yeah,
And that's why I did it, because I figured people would go, wait. But yeah. So that is 1 and that's 2 now. Doesn't matter which way we go.
and then for it's the on the last thing we did on page 21 with that like 1,2-diphenyl benzene.
Yeah.
Where do we get the 1 and 2 from?
So it's either this is 1 and this is 2, or this is 1 and this is 2. So imagine if we put another one on here.
So that like bottom left one's like it's a central benzene.
That's the thing. It doesn't matter. As long as we name one of them 1, then this would be 1, 2, 3 triphenylbenzene, right? Doesn't matter.
Could you still name it if like you picked that very top benzene as like your main benzene?
No. Then you could not use the naming system that we know, because this is too big. That's why we have to pick the one that they're all coming from. That is, I see what you're saying now. This is our main benzene.
Mm-hmm.
These 3 are substituents coming off of it.
Okay. And then my last question is, where do we get the name like toluene, like hike?
To tell you the truth, I don't know where toluene came from, but it is a generic thing. Like it's a name, like it doesn't use the system that we have. Let's see. Let's look it up real quick. Toluene.
I didn't know if it was like a prefix like the meth, ethyl, and like pro-bute that we had to know.
The older name toluol, which refers to tolo balsam, an aromatic extract from the tropical American tree Myroxylon balsamum. So yeah.
All right, that's all I had. So thank you.
Cool. Hey, you're welcome. I hope that everything's going good for you at home and stuff.
Oh yeah, I'll probably be virtual for the next like month because like I have swimming and our coaches like want us to be like avoid any risk possible. So like because we have to do like state soon in sectionals.
Yeah,
So
right.
they went down a little bit, but after it's all said and done, I'll come back.
All right, cool, man. Have a great day.
You too.
You can tell her. Oh. You. Like that. What are you making those orbital? What's that? What do you do? What do you do? I actually had one made, but I think it's broken. It's real cool after you get it all made. Let's go ahead and make one. Because there's one, like if you make it for one class, then it doesn't get made, right? It doesn't get made for one anyway. Not working? gonna put it here. Though. If you're like, if you don't take the time. Yep. I forgot to stop recording, didn't I?